Welcome to all of you in a seventh international conference on biofuel and bioenergy. Welcome to all of you. Myself, Dr. Mukul Machindra Barwant, Dean of Research Development and Assistant Professor Sanjeevani Arts Commerce Science College. Title of my presentation is Harnessing Sargassum Biomass for the Bioethanol, Biodiesel and the Biogas Production. Let's see introductions of sargassum biomass. Sargassum, it is one of the marine brown microalgae that are found in from the class Phaeophyceae. Over 350 species identified in a worldwide. Occurs in a coastal habitat and the open oceans. They are the fast growing and high biomass productivity. They are having the rich source of carbohydrate, minerals, bioactive compounds, and the number of phycocolloids producing ability of that sargassum. So it can be having the number of applications. So why it is important? First, they are the abundant biomass marine from the marine resources. They are having the abundant biomass productions. There is no any competition with the other agriculture crops. It does not need any fresh water requirement for the growth and developments. For its growth and development, it's need a seawater or the salt water. It is important in the view of suitable for the biofuel production and the bioproducts. It is the eco-friendly resources, support the circular bioeconomy and the blue economy. So sargassum it having the both type of importance in a eco-friendly also and the renewable sources also. So global distribution and the availability of a sargassum. Sargassum, it is called as basically found in a Pacific Ocean, Sargasso Sea, Indian Oceans, and the Great Atlantic Sargassum Belt. That is called as a GASP. There is distribution. Sargassum, it is found in all overall world. Those having the coastal lines, widely distributed in tropical and the subtropical oceans. Common in coastal waters, coral reefs, pelagic environments, exist as both attached and the free floating forms. They forms the extensive floating mat across the ocean currents. There is availability. Annual blooms generate the millions of tons of biomass. Massive accumulation reported like Caribbean Sea, Gulf of Mexico, West African coast and Central Atlantic oceans. They having the great availability of that sargassum biomass. Great Atlantic sargassum belt is a there is a larger producer of a sargassum, largest floating bloom system. They extend in a West Africa to the Caribbean, thousands of kilometers in a length. They provide the continuous and abundant feedstock for a bioenergy and the bio refinery. So it's a distributed in all overall worlds, and production of biomass is more as compared to other any type of feedstocks. So what are the significance of when we are using as a renewable sources of sargassum? First, there is a environmental importance. It mitigate the coastal pollutions. Then it's supposed to the circular bioeconomy, reduces the greenhouse gas emissions, no fresh water requirement. So that are the some environmental importance. Another type of they having the cleaner coast, resource recovery, lower carbon footprints, they conserve the waters. Then sargassum blooms, harvesting, processing, then the number of biofuel production can be done. So it is one of the way of a sustainable economy we can say. Then the advantages over terrestrial biomass. There is a several advantages. Terrestrial biomass, it is one of the agriculture fields, but it is having the oceanic field, so it can be useful in every way. Let's see the features of sargassum biomass and terrestrial biomass. That are the areable land requires. For the sargassum, there is no need of a land, but in for the terrestrial biomass, there is a need of a land. Then the fresh water requirement. For the sargassum biomass, there is no need of a fresh water requirement, but for the terrestrial biomass, for the growth of agriculture crops or the agriculture biomass, they need a fresh water. Competition of with other food crops. Sargassum does not compete with the any type of other food crops, but terrestrial biomass it feeds with the others. Then the fertilizer requirement for the sargassum growth or the cultivation or the production of biomass, there is a no use of fertilizer or no need of fertilizer is needed. But in comparison with terrestrial biomass, there is a need of application of fertilizer. Then the harvesting potential, as per the commercial costing is there in a sargassum, there we can say that is a 5 times is better than the terrestrial biomass, because there is no need of any expert or the any mechanical instruments. They need only a skilled persons. Then the carbon footprint, it will be increases by using the sargassum biomass. Then the environmental remediation, sargassum biomass, it is a helpful over the terrestrial biomass. So all sense we can say that is a sargassum biomass, it is a useful for the production of biofuels. Biofuel production, we can't say on the basis of thought, but it's a biochemical composition of sargassum tells that they having the ability to produce the biofuels. Like a sargassum biomass having the potential of a carbohydrate 30 to 60%, lipid 1 to 5%, mineral 15 to 35%, and the rich diversity of bioactive compounds along with the protein 5 to 15%. So having the multifunctional biomass, rich carbohydrates, minerals, and valuable biocompounds suitable for the integrated the biorefinery applications. So it can be say the one by one carbohydrate we call as the phycocolloids. Major bioethanol feedstock is prepared from the phycocolloids of the carbohydrate like alginate, fucodines, laminarin, mannitols. That are the some carbohydrate derivative are useful for the production of bioethanols like sargassum harvesting, then the pre-treatment, hydrolysis, its conversion into sugar, then fermentation, and lastly it prepare the bioethanol. So it is easy for the preparation of a from carbohydrate to a bioethanol feedstocks. Then the lipid are useful for the biodiesel productions, like as a major derivative of lipid like a fatty acid, triglycerides, and phospholipids, that are the useful for the biodiesel production, like a sargassum collection, lipid extraction, transesterification, and then it's converted into bioethanol or the biodiesel productions. So it is one of the easiest way of biodiesel productions. Then the protein having the nutritional as well as the industrial value, like as a protein function we call as enzymatic activity, nitrogen source, microbial fermentation, and the nutraceutical potential. So it can be useful for the different types of a biomass. Then the minerals and bioactive compound, they having the high value compounds. Minerals and bioactive compounds, minerals they having the several macro elements as well as a trace element. Macro element like potassium, calcium, then the magnesium and sodium, it's having the own function. Like potassium is useful for the osmoregulation, enzyme activation. Then the calcium is useful for the cell structure signaling, photosynthesis, metabolisms. Number of way of application are there macro elements. Then the trace element like iron for the etc, or we call it the electron transport. Then the zinc for the enzyme cofactors, manganese for the antioxidant enzymes. Some bioactive compounds also are there like a polyphenol, fucoxanthin, flavonoid, sulfated polysaccharides, that's having the own its function like a natural antioxidant, then the health promoting property, free radical scavenging, bioactive compounds with the potentials. So that are the some function. So sargassum, it is one of the superior marine feedstock for the biofuel production. Advantages over the terrestrial biomass. As earlier we have seen, the terrestrial biomass need a land requirement, fresh water requirement, competition with the food crops, lignin rich structure, fertilizer, and the pesticide dependencies. As a comparative or the application side, there is no land requirement, no fresh water requirement, no competition with food crops, rapid biomass growth. uh, Low lignin content, easy to conservation, into the bioethanol, biodiesel, and biogas. Utilize the coastal biomass blooms. Then we can see the sargassum is a circular bioeconomy framework. Sargassum can be used in a bioeconomy framework. As we have studied the natural sargassum biomass collection will be there. or the cultivation is there. Then the collection of biomass, biorefining process are there, bioethanol, clean liquid fuels are there, then biodiesel, renewable transport fuel are there, then the biogas, renewable energy can produce, biofertilizer can be produced, a reduced waste can be a carbon emission and return to the sustainable ecosystem. So it can be useful for the circular bioeconomy framework. Then the pre-treatment of sargassum biomass for the bioethanol production. So pre-treatment is nothing but after the collection of a raw sargassum biomass, we have a pre-treatment, that is a disruption of the complex structures, then the release of a sugar by the increasing the accessibility of a carbohydrate, and then the bioethanol production can be proceed. There are the major pre-treatment method like physical pre-treatment method is milling and grinding, thermal treatment, steam explosion. Then the chemical pre-treatment are there, dilute the acid treatment, alkaline treatment, oxidative pre-treatment, enzymatic treatment, and the microbial degradation are there. So in this way we can pre-treated to a production of sugar, and then bioethanol can be a possible. So in this way we can see that is bioethanol can be a proceed with the help of a sargassum. Then after the sugar synthesis or the sugar extraction, then we go to hydrolysis, or we call the fermentation of sugars, like complex polysaccharides like alginate, laminarin, mannitol, cellulose. They undergo the hydrolysis process, breaking down by the enzymes acid catalyze breakdown into the polymer like a glucose, mannose, and other monosaccharides. That is one of the process we call as a hydrolysis, that is useful for the conversion of complex polysaccharides into the monosaccharides compounds. So it is useful for the production of biofuels. Fermentation of sugar into the bioethanol, like as fermentable sugar into the microbial fermentation, then the bioethanol, and then the renewable energy resources can be done. There is a common organism can be used for the fermentation, like yeast or the bacteria like Xanthomonas. Then the fermentation technique like a separate hydrolysis and fermentation, simultaneous saccharification and the fermentation, and consolidated bioprocessing techniques are useful for. During that process, we have take care about the temperature, pH, retention time, and sugar concentration. All things will be considered in a fermentation of a sugar bioethanols. Then the enhancing the bioethanol production from a sargassum. So how we can enhance the bioethanol production from the sargassum? First, we have due to the pre-treatment, improve the disruption of cell wall and carbohydrate accessibility. Then the enzyme engineering, enhance the enzyme activity by stability for the efficient saccharification. Then the strain improvement, robust the stress tolerant, high yielding fermentative microorganism. And then process integration, simultaneous saccharification and the fermentation for the higher efficiency. Then artificial intelligence and the process control, real time monitoring of a predictive analytic and the smart control for the optimal performance. So in this way we can enhancing the bioethanol production from the sargassum. Then the biodiesel production from a sargassum. So it is a similar process. Biodiesel is specially extracted from the lipid, or the synthesis from the lipid it can be done. Lipid extraction techniques. First they are the solvent extraction, mechanical extraction, and the advanced method extraction of lipid can be done, such as a hexane, chloroform methanol, ethanol based extraction, pressing homogenization, ultrasound assisted extraction, microwave assisted extraction, supercritical CO2 extractions. So in this way we can extract the lipid through crude oils, and then it will be useful for the biodiesel production. So biodiesel production, it is a simple way extraction of lipid, that means that into a methanol or ethanol, catalyst will be added like NaOH, KOH, and then the transesterification will be done. And during the transesterification, two different products are formed. Our commercial product we call as a biodiesel are formed, and non-commercial product we call as a glycerol product will be a form. The type of catalyst like alkali catalyst, NaOH, KOH, acid catalyst, and enzymatic catalyst are used. So that is a biodiesel production from the sargassum lipids. Then the biodiesel production from the sargassum, there are some factors are responsible, like temperature, lipid composition, moisture, reaction time, alcohol to oil ratio, catalyst concentration. All these factors are responsible during the conversion of a lipid into the biodiesels. So that our factor are responsible. Then the biodiesel production, there are some properties and application. That biodiesel prepare from the sargassum lipid, they having the fuel properties like high certain number, renewable, biodegradable, low sulfur content, good lubricity, reduce greenhouse gas emissions, cleaner combustion. Then the transportation of vehicles, agriculture machinery, marine engines, industrial equipment, and the renewable energy systems. So that are the some properties and application of a biodiesel from the sargassum lipid. Then the biogas production from the sargassum, there is a one specialized process we called as anaerobic digestion process, through which sargassum are useful for sargassum is converted into the biogas. Sargassum biomass collection will be there. Then the pre-treatment, size reduction by a thermal chemical treatments. Then the anaerobic digestion will be there. In anaerobic digestion, there is a biogas production will be there, like ch3 and co2. Then it is after the biogas application, they are digested, it can be used as a biofertilizer, because they are having the high nutrient value. During that process, some other processes also take place, like hydrolysis, acidogenesis, acetogenesis, and the methanogenesis. Hydrolysis, that is a complex organic matter into the simple compounds. Acidogenesis, that is a simple compound into the organic compound, and the organic acid to the acetate, we call it as acetogenesis, and the uh, acetate into the methane. So that our processes are during take place during the anaerobic digestion processes. So it is in this way we can produce the biogas from the sargassum biomass. Biogas production from the sargassum, there is the same way are there. Some are the organic matter content, then the cn ratio, salt concentration, temperature, ph, retention time. So all things will be consideration for the biogas production. We also call it as a methane production. Then the biogas production, there is a process optimization, such as pre-treatment enhancement, microbial community management, process control, monitoring automation, reactor design improvement. Such things will be observed. Then the biogas production from the sargassum, that is a co-digestion approach, like a sargassum biomass plus animal manure plus agriculture residue or the food waste, along we can useful for the production of a biogas by the co-approach with the sargassum with the other feedstocks. Then the sequential production of biogas, bioethanol, and the biodiesels, such as the sargassum, we can sequentially produce into the bioethanol, biodiesel, and biogas, like carbohydrate, lipid, and the residue solid waste, that will be converted into bioethanol, biodiesels, and the anaerobic in biogas. And the last product we can use as a bio fertilizers. So it can be useful for the production of that techniques. Then integrated biorefinery approaches, that is valorization of byproducts like bioethanol, biodiesel, and biogas. The valuable byproducts from that is a residual sugar, fermentation residue, from biodiesels glycerol, fatty acids, and from the biogas digested and nutrient rich uh, slurry that can be produced by using the during the production of bioethanol, biodiesel, and the biogas. So it having the valued byproduct also prepared during the that process. Integrated biorefinery waste minimization strategy, the sargassum biomass, that is a fractionation and the processing, that is bioethanol, biodiesel, and the biogas. Then the circular bioeconomy, recovery of remaining materials, and the biofertilizer and the value added product can be a synthesis. So it is a integrated biorefinery industry. We can see that is environmental and economic perspective. Environmental first, that is a carbon footprint reductions. So during that sargassum based biorefinery, there is a carbon footprint reduction can be done. That is a lower greenhouse gas emission, carbon sequestration, renewable and the sustainable energy, coastal ecosystem protection, circular resources utilization, then the reduce carbon footprint. So all these things can be possible by using the sargassum feedstocks. Then the life cycle assessment, that we call as a LCA, life cycle assessment ratio, we can see that is sargassum can be useful for the harvesting, transportation, pre-treatment, then the biofuel production, distribution, then byproduct, recycling, and that is a one type of a life cycle assessment can be done. That will be indicate that is a global warming potential, energy balance, water footprint, eutrophication potential, resource depletion, that type of indicators we can see that. Then the techno-economic analysis. There is a very low cost and economic indicator as well as a benefit overall outcome. It is a very good. We call it as a raw material, collection, transport, processing and the conversion, utilities, operations and the capital investment. Then economic indicator, there is a total capital investment, operating cost, revenue from the biofuels, revenue from byproducts, and the payback periods, and NPV, that is a net present value. Then the benefit, multiple biofuel product, high value from the byproducts, waste minimization, job creation, and the economic sustainability. And overall, we can say that is economically viable and environment friendly biorefinery systems. Then some challenges during that cultivation or the production of biofuels, like season variation of sargassum biomass. There are the spring season, winter season, summer season, and monsoon season. During the monsoon season, we got a very low amount of biomass, but in the remaining three season, we get a proper type of biomass. Season fluctuation, environmental influence, and supply chain challenges. So such challenges we have to face during that is production of biofuels. Then another challenges like high ash and salt content. That when we are the harvesting that sargassum, but during the extraction we get a other component like high salt content as well as high ash content. So it will be for, difficult for the production of a biofuel. Then they having the facing another problem like equipment corrosion risk, equipment corrosion, pre-treatment complexity, reduce conversion, and the increase the processing cost. That are challenges we have to face. Then another challenge is that is the processing and scalability issue. Sargassum biomass pre-treatment, conversion technology, industrial production, and the commercial deployment. So that are the challenges during the processing and the scalability, so we can face. There are some recent advances and technologies are including, such as a sargassum based biorefinery 4.0. In that, genetic metabolic engineering as well as advanced pre-treatment methods and artificial intelligence and process optimization, some techniques are used for the production of biofuels. Then the genetic engineering for the enhance the biofuel production, like a CRISPR-Cas system, gene editing, synthetic biology, and functional genomics. That are the some genetic engineering useful for the biofuel production. So it is a one type of improvement or the recent advances in a biofuel production. Then the metabolic engineering useful for the biofuel pathway, like a sargassum biomass, then sargassum sugar production, engineer microorganisms. So it is helpful for the increasing the biofuel production within the low timing, we can say that is then the advanced pre-treatment technology also used for the easy production of or the easy production of biofuels, like a microwave assisted pretreatment, ultrasound assisted pretreatment, hydrothermal processing, ionic liquid pretreatment, deep eotic solvents. So such type of advanced technique are there for the production of biofuels. Then some artificial intelligence and the process optimization, AI in a biofuel production, AI application, and the some key and the some higher productivity, lower operational cost, and the faster optimization. Such techniques are used by using the artificial intelligence. And the some future and smart biorefinery perspective. Sargassum feedstock is a abundant and renewable biomass. AI driven processing, engineer microorganism, advanced pre-treatment. So it is a useful for the circular bioeconomy and zero waste and the maximum value. Then the carbon neutral biofuel system, industry 4.0 biorefineries, IoT based monitoring, AI guided process control, and zero waste biomass utilization can be done. There are some case studies such as the global research progress. Nowadays, research growth are the 350 plus research articles from 2050 to 2024. 250 university and institute involved in that research, and 40 plus countries contributing in such type of research. So that is global research progress will be there. Some commercial developments. Then industrial application like alga energy, sargassum, bright mark, sea energy, and rails, bioethanol production, biogas fertilizers, advanced biochemical, biodiesel, and multi product that are in a different location that are working. So it can be interested, that is a industrial industry as well as some pilot project are running. Then we called as a some future prospect like policy markets opportunity, a role and sustainable energy. So it is a important future prospect we called as the advanced biorefinery technology, then the sustainable cultivation and the reliable supply, high conservation efficiency, and the cost of reductions. Then the policy, supportive policy we have to implement, jobs, local industry development, investment and market expansion, lower emissions and climate impacts, uses of a problematic coastal biomass, promote the circular economy, and enhance the energy security, support to the sustainable development goals. Conclusion of our presentation or our work, that is a sargassum biomass. It is a promising renewable feedstock for the producing the bioethanol, biodiesel, and the biogas, offering the environmental friendly alternative fossil fuels. Valorization of sargassum transport into coastal waste problem, valuable resources energy resources for the reducing the pollution while the creating the economic opportunity. Advances in a biorefinery technology supporting policy, strategic investment, and can be accelerate the commercialization, improve the economic viability. Sargassum based biofuel, integrating the sargassum in a circular bioeconomy, production of a renewable energy alongside of high value co-products, maximizing the resource efficiency. Harnessing of a sargassum for the biofuel production contributes significantly global decarbonization, energy security, then the sustainable development, making it an important component of the future blue economy. So thank you for the giving attention and listening these sessions. I'm thankful for the international organizing committee of conferences. And if you have any research doubts or the presentation doubts, you can email me on given email ID. Thank you.